Hello everyone, good afternoon to all guys. Is my voice clearly audible to you all? Yes. Is my voice clearly audible to you all guys? Yes. Is my voice clearly audible to you all? Okay, so let's start. So, okay, so today we are starting the new topic, that is limit, continuity and differentiability, right? So first, before this topic, already you have completed determinant matrix, quadratic equation, complex number, PNC, and also probability also. है ना? Sir have taken already 2 or 3 classes on probability, right? So today we are going to start the calculus portion, that is starting from limit on limits. So some advanced questions will be discussed in this session, right? So let's start with our first question. So what is the first question it is asking? Actually, the importance of this topic is actually high. So if you'll consider of this topic in perspective of JEE Advanced, so actually this covers limit, continuity, and differentiability. Three chapters coming under this unit. Okay. So first is I would like to say at least you will get 2 questions from these portions. 2 to 3 questions you will get in JEE Advanced. 2 to 3 questions from this portion. So मैं तुम्हें ये बताऊं कि if you are very much comfortable with calculus and already you have studied these portions very clearly and you are very much confident about the concept of all these chapters, then you must go through these topics and you will attend or you will answer the questions will be coming in JEE Advanced. Okay, so let's discuss the first questions. What is it is asking? So the first question is like this: if an and bn are positive integers, okay, so it is given that an and bn are 2 positive integers, both are positive integers, and n plus root 2 bn is given as 2 plus root 2 whole to the power n, right? Then you need to find limit n tending to infinity n upon bn. Is that or not? Okay. So one thing, there is nothing to worry about these questions. Actually, you must understand the questions. You must see what it is given in the questions. If you are observing what is given in the questions, then it will be easy to solve the questions. Okay. So let's see, it is given in the question that an and bn, right? an and bn, sorry, ये दोनों ना both are just a minute. An and bn both are positive integers. Okay, and also it is given that an plus root 2, what exactly, just a minute, it is given that an plus bn root 2 bn, an plus root 2 bn, pen is not working. It is given that 2 plus root 2 to the power n. Okay. So you can see, or you can tell me, if an and bn are integers, positive integers, then if I'll ask you, so what will be an minus root 2 bn? If an plus bn, an plus root 2 bn is equal to 2 plus root 2 whole to the power n, then what will be an minus root 2 bn? If an and bn are positive integers, right? If an and bn are positive integers, it is given, right? So let's check me what is happening actually. Oh, where is it? Yeah. So tell me now, what am I asking? An minus root 2 bn. What will be an minus root 2 bn? So this will be actually 2 minus root 2 whole to the power n. Now, if I'll ask you to add these two, if I'll ask you to add these two equations, so what you will get? See, let's see. If we'll add these two equations, what we are getting? We are getting 2 into an is equal to root 2 bn. Root 2 bn will be cancelled out. So 2 into an will be 2 plus root 2 whole to the power n plus plus 2 minus root 2 whole to the power n. So an will be, actually my pen is not working, guys. Just a minute. So no. So an will be 2 plus root 2 whole to the power n plus 2 minus root 2 whole to the power n whole divided by 2. So from here we are getting an, then what will be bn? How we can find bn actually, right? So let's see, if we'll subtract, if it is my equation 1 and it is 2, if we'll subtract from one another, okay? So here, from here, by subtracting, what we'll get? We'll get, by subtracting, what we'll get? By subtracting, we'll be getting bn is equal to 2 plus root 2, sorry, 2 plus root 2 to the power n minus 2 minus root 2 to the power n whole divided by, we'll getting 2 root 2, right? So from here we got an and bn. Now you can easily find an upon bn, right? So what you are getting, an upon bn? So an upon bn will be this upon this, that is 2 plus root to the power n, 2 plus root 2 whole to the power n plus 2√2 whole to the power 2 plus √2 to the power n minus 2 minus √2 whole to the power n. Now, we cancel out, right? You are having what you are having actually, na? So let's see if you'll put limit here, so it will not work, right? So what we'll do one thing, we'll divide 2 plus √2 with numerator and 2 plus √2 whole to the power n with numerator and also with denominator. So what you are getting after dividing, we are getting √2. Here we are dividing 2 plus √2 whole to the power n with numerator. So after dividing, what we are getting? We are getting 1 plus 2 minus √2 upon 2 plus √2 whole to the power n divided by 1 minus 2 minus √2 upon 2 plus √2 whole to the power n, right? So it is I am getting actually. Now we know, so this is actually, you can see 2 minus √2 upon 2 plus √2, right? 2 minus √2 and 2 plus √2 is actually less than 1. If it is less than 1, then if we'll put limit here, if we'll put limit n tending to infinity, right? If you're putting limit n tending to infinity, then this will be, suppose here I'm also putting limit n tending to infinity. So this will be 0, and this is also 0. This will be 0, right? Yes or no? So limit, what we are getting, the answer will be, this will be 1 plus 0 upon 1 minus 0. So this is actually, the answer is √2. Clear? Answer is √2. Clear everyone? Okay? Done. So I hope this is clear to everyone, guys. This is the first questions we have discussed. Okay, actually my pen is not working. Why it is happening, I don't know. Let me check again. Yeah. So let's move to the second question. So here it is given, oh, Sn is equal to 3 upon 1 into 2 into 4 plus 4 upon 2 into 3 into 5. Okay, so it is given Sn is equal to 3 upon 1 into 2 into 4 plus 4 upon 2 into 3 into 5 plus 5 upon 3 into 4 into 6 and so on up to n plus 2 divided by n into n plus 1 into n plus 3. So see, it is asking to find the limit of Sn. Okay, so if it is my Sn, so how can we write also Sn by using the summation formula? So Sn को हम ऐसे भी लिख सकते हैं, that is Sn is equal to, we can write this as summation r plus 2 upon n into n plus 1 into n plus 3, right? Is it or not? We're getting, okay? So see, actually limit से ज्यादा यहाँ पे हम क्या यूज कर सकते हैं? We know what is Vn method. In sequence series already you have studied Vn method, right? if you use VN method, or you can say that cancellation method, cancellation method. Okay, so see, commonly when you are using VN methods, what we will be doing actually? You can see here, or you can observe here in the denominator, in the summation or in the expression, what you are getting, nth term we are getting, that is in the denominator you are having n into n plus 1 into n plus 3. So it is not following a particular pattern. So to complete the denominator, or to follow the denominator to be followed a particular pattern like that, you can say a normal sequence, it must be a normal sequence to apply VN methods, like n plus 1 into n plus 2 into n plus 3, or you can say n plus 4 into n plus 8 into n plus 12, like this. So to complete the denominator, so what we need to do, so what we do, I'm writing the denominator first, that is n into n plus 1 into n plus 2 into n plus 3, like this. Okay, so how we are multiplying a new n factor n plus 2 with denominator, and also we have to multiply that factor with the numerator also, that then this will be, oh actually this is not n, okay, this is not n, this is r into r plus 1, you can write n, no problem. Okay, so already we have taken r as this is r plus 1, r plus 3, so r plus 1, r plus 2 into, because in the question it is given in the form of n, that's why I'm taking r into r plus 1 into r plus 2 into r plus 3, and numerator becomes r plus 2 whole square. Now it is, now what is the next step? What should you follow? What should you do? Now let's see. Now you can do, write this, if you'll open this, okay, if you'll open this expression given in the numerator, what you are getting, r square plus 2r plus 4, right? Okay, so in the second step, what should you do? We must have take two factors present in the denominator and multiply, and try to bring that, after multiplying what you are getting, try to bring that in numerator. Okay, right? So see, we are I'm multiplying here r plus 1 into r plus 3. What you are getting? By multiplying r plus 1 into r plus 3, what you are getting? We are getting r square plus 4 plus 2r. Is it or not? What you are getting? 2r or 3r you are getting? R square plus 3r plus r, right? How 4r you are getting, na? R square plus 4r plus 3 you are getting, right? Okay, let's see. If you'll open it in the numerator, what you are having, if you'll open it, so what you are getting, r square plus 4r plus 4. Is it or not? But when you are multiplying r into r plus 1 into r plus 3, what you are getting? We are getting r square plus 3r plus r plus 3. Is it or not? So already we have 4r and already 4. So to I am writing 4 as 3 plus 1. 4 as, just write 4 here. Then we are getting r into r plus 1 into r plus 2 into r plus 3. Is it or not? This is, you are getting or not? So can we write this numerator as r plus 1 into r plus 3, r plus 1 into r plus 3 plus 1? Yes, we can write. And this will be r into r plus 1 into r plus 2 into r plus 3, right? Now we can easily apply the VN method. Okay, let's see. If you use the VN method, what you are getting? See here, we are getting here r, when we'll divide r plus 1 into r plus 3 with the denominator, what we are getting? Summation, this will be cancelled out, 1 upon r into r plus 2 plus 1 divided by r into r plus 1 into r plus 2 into r plus 3 we are getting. Is it or not? Guys, we are getting or not? Right or not? Yeah. Now I will be suggesting to write, see, you must have a constant in the numerator when you are applying the Vn methods, right? So here we are having 1, right? And also, if you'll apply again the Vn method here, what you are getting? See, if you'll okay. So next step, what should you do? You must try to bring this 2 in the numerator, right? Because see, if we'll multiply 1 by 2, multiply with 2 and divided by 2, then what you are getting? Half into summation of numerator becomes 2 divided. Acha, this 2 can be written as, r plus 2 minus r. Is it or not? Then r into r plus 2. I can write or not? Yes, I can write. Similarly, plus here I am dividing 3 and multiplying by 3 also. So this 3 can be written as also r plus 3 minus r. Is there any problem? No. So r into r plus 1 into r plus 2 into r plus 3. Right? Okay. See. Now open the summation. If you open the summation, actually it's a question, I can say it's a question from sequence and series, right? Okay, let's see. By opening the summation, what you are getting? Half into, I'm trying to open the first expression. I'm trying to open this one. Half into, when you apply this one, is summation r plus 2 will be cancelled out. So this will 1 upon r minus 1 upon r plus 2. Right? If you open this, what we are getting? See, let's see. Half into 1 upon 1 minus 1 upon 3. Okay. Plus 1 upon 2 minus 1 upon 4 plus 1 upon 3 minus 1 upon 5 plus 1 upon 4 minus 1 upon 6 and so on. You can see here, beta, what are the terms you can cancel here? So 1 by 3, 1 by 3, and here 1 by 4, 1 by 4 cancel out. So the second term is always cancel out, right? So in finally what you are having? I am having 1 by 2 into 1, this term, 1 plus 1 by 2, and in the last term, what we will be having in the denominator, you will be having n. In terms of n, you will be having with the denominator. Then when you will apply n tending to infinity, this becomes 0. So 1 into 1 half into 1 plus half, that is 1 by 2 into 3 by 2. So this becomes 3 by 4. So, okay. So this becomes 3 by 4. Now, if we'll take this one, okay, 1 by 3 into, now try to open this one. I'm taking this to next. Okay, let's see. If you'll open this one, what will be happening? See here. Okay, so this becomes 1 by 3 summation. When we'll divide r by r plus 3 upon the denominator, I am getting 1 upon r into r plus 1 into r plus 2 minus, this becomes 1 upon r into r plus 2 into r plus 3, right? So now try to open this or apply, open the summations. What I am getting? 1 by 3 into, this becomes 1 upon 1 into 2 into 3, 1 upon 1 into 2 into 3 minus 1 upon, also r will be cancelled out now. So this becomes 2 into 3 into 4. So this will be the first, plus 1 upon 2 into 3 into 4 minus 1 upon 3 into 4 into 5. Right? So similarly, go on. Then you can see each second term will be cancel out. ये सारे terms cancel out हो जाएंगे, and जो भी terms तुम्हें last nth term में मिलने वाला है, in the nth term you will be getting the denominator with n. So when you will apply the limit n tending to infinity, then the last term will be 0, right? So from here also you are getting 1 upon 3. So this becomes 1 upon 6. So this will be 1 upon 18. Okay. So finally what you are getting? You are getting actually 3 upon 4. The answer will be 3 upon 4. This is 3 upon 4. And this is 1 upon 18. Okay, 3 upon 4 and 1 upon 18. 3 upon 4 plus 1 upon 18. So the LCM will be 36. And this will be 27 plus 2. So this answer will be 29 upon 36. Okay. So constant you are getting. When you apply also limit, then no need to be worried. Limit apply kar kuch bhi. So 29 upon 36 will be your answer. 29 upon 36 will be your answer. Is that clear to everyone, guys? Let's see what is the answer. 29 upon 36. Option B is your correct one. Okay? Option B is the correct one. Okay. So this is the answer of second question. Any doubt you can ask also here. If you have any doubt, you can ask me. Right? Okay. Oh. Okay. Let's move to the third question. Okay. So what is asking actually? Let's see. It is given that if f is a function which is mapping from r plus to r plus. So it is given f is a function which is mapping from r plus to r plus. Okay. Chalo. It is satisfying the relation given that f of x into f of y is equal to f of xy plus x. For all xy belongs to also r plus. Okay, no problem. And also it is given that if f is a polynomial function, okay, it is given that f is a polynomial function, then what is the limit of this expression of this function? Okay. So before going through finding the limit, you must have tried to find what is f of x actually. Okay. So how we can find f of x, and it's a functional equations, right? So you can use the method of function, how to solve the functional equations, and it will be lengthy actually if you use the functional equations method. Okay, it will be very lengthy. Let's see. You can solve it by this method also, functional method also. So if you observe the given functional equation, this if you observe this given functional equations, you can see in the right hand sides you are having f of xy plus x, right? And in the left hand side you are having f of x into f of y. Okay. Then if I'll ask you to let's take the degree of the right hand side, not right hand side, degree of this function in y, degree in y is n. If I am saying this is the function, the degree of this function is n degree in y. Okay. If this is the function of degree n in terms of y, so then can you tell me what is the degree of this left hand side will be? So this is if in the right hand side, so if you are having f of xy, right? But in the left hand side, you are having f of x into f of xy, f of y, right? F x into f of y. So if this is here in the right hand side, the degree of f of xy is n, then f of x into f of x y की degree क्या हो जाएगा? So this will be n and f of fy ना, f की डिग्री n है तो f of fy की डिग्री क्या हो जाएगा? n square, right? So this will be of degree n square in terms of y, right? So you can see in the right hand side you are having the degree as n, and in the left hand side you are having also the degree as n square, right? So if you compare, so this is actually left hand side is equal to right hand side, so n square must be equal to n होना चाहिए. Otherwise, if n square will not be equal to n, then it will be not satisfying, na? It is given that it's a polynomial function, right? It is f is a polynomial function, right? You can take f of y as y square, you can take f of xy as x into y square, you can take. Then you try to find f of x into f of y, you will get the degree will be 4. Yes or no? So then this functional equation to be satisfied, the power must be equal left hand side, the degree of the left hand side must be equal to the degree of right hand side. Then this will be n square is equal to n, right? So from here we are getting n is equal to either 0 or 1. Okay, either 0 or 1. Okay, we cannot take 0. Why we cannot take 0? Because if we take 0 as degree, then it will be, if this in here it is 0 and this is also 0. Okay, if we'll put 0, so what you will be getting? If you will say this is the function of degree 0 and this is also function of degree 0, then you are also having living with x, na? So 0 we cannot take. Okay, so let's take n is equal to 1. Okay, if we take n is equal to 1, that means if we are taking the degree as 1, then it must be a linear function. So I am taking, let's say f of x is equal to ax plus b. Okay, so this is the linear function of degree, right? Is it or not? So from here we are getting f of x as ax plus b, right? Okay, if f of x as ax plus b, can you say what will be f of y? Then f of y will be, okay, so this will be, if f of x is equal to ax plus b, then f of y will be, so this will be f of y will be, what will be happen? So f of y will be ay plus b, right? So f of ay plus b will be a into ay plus b. Is it or not? If it is ay plus a into ay plus b plus b, na? Yes or no? Right? So this is actually equal to f of y, right? So f of y becomes f of ay plus b, which is equal to f of y plus 1. Na? From here we can say this is equal to f of y plus 1. Yes. So, and from here f of y becomes, you can say f of y becomes ay plus b plus 1. Okay, so we can say here we are getting a square y plus ab plus b is equal to ay plus b plus 1. From both the sides, we can cancel bb from both the sides. And what we are leaving with a square y plus ab is equal to ay plus 1. Okay. So I am telling you now, if you'll take y is equal to 1 in both sides, if we'll take y is equal to 1 on both sides, what we are having with? We are having with a square plus ab is equal to a plus 1, right? A plus 1. Okay. So a plus 1 you are having, right? Then this is my, suppose I am taking, this is my equation 1. Okay. Now I am asking you to take, I am trying to simplify the given functional equation. I am trying to find the given function. Okay. So from here we are getting the relationship between a and b as a square plus ab is equal to a plus 1. Okay. If you are getting this one, then now if I'll tell you to take y is equal to 0 and x is equal to 1 in the given function. Okay. Y is equal to 0 and x is equal to 1, right? So this will be f of y is equal to 0 now. It is given that x into f of y, which is equal to f of xy plus x, it is given now. Okay, so if we'll put this in this, so we are getting f of 0, f of 0 is equal to, this becomes f of 0 plus x is equal to 1. So here we are getting this one. Okay, so let's see. F of 0 will be b, or f of x we have taken ax plus b. So f of 0 will be b na. So f of b is equal to f of 0 plus 1, that is f of b is equal to f of 0 as b na. So b plus 1. So f of b is actually ab plus b is equal to b plus 1. So from both the sides b will be cancelled out. So we are getting ab is equal to 1 here. So this is my equation 2. Okay, so if we'll use this ab is equal to, value of ab is equal to 1 in this equation 1. So what we are living with? We are getting, if we'll put here ab is equal to 1, we are getting a square is equal to a also. That means we are getting either a is equal to 0 or 1. Okay, so a is equal to 0 or 1. Okay, so here also we cannot take 0, because if we take 0, a as 0, then the equation will be the degree of 0. The given functional equation will be the degree of 0. And in case of degree 0, the functional equation is not satisfying. So that's why we cannot take the 0, a as 0, because if you put 0, a is equal to 0, then the function will be, this function becomes b, and this is a constant function of degree 0, and for degree 0 the given functional equation is not satisfying, right? So a is equal to, a has to be 1. If a is equal to 1 and ab to be 1, then b must be, so that means a is equal to b is equal to 1 you are getting. So my function becomes f of x is equal to 1 plus x to the power n. Right? No. 1 plus f of x we have taken f of x we have taken, that is x plus b, that is it becomes 1 plus x. Okay, now come to the given questions. It is given that it's given that f of x to the power, okay, let's take this question. Okay, so already we have taken this thing. So what we are getting here, we are getting f of x is equal to 1 plus x. If you are getting f of x is equal to 1 plus x, then this will be limit extending to 0, 1 plus x to the power 1 by 3, okay, minus 1 divided by 1 plus x to the power 1 by 2 minus 1, right? Now you can see if you put extending to 0, so this limit will be in the form of 0 by 0. Okay, then we can easily we can use the L'Hopital rule easily, right? So use the L'Hopital rule. So limit extending to 0, this becomes 1 by 3 into 1 upon 1 by 3 into 1 plus x to the power 1 by 3 minus 1 minus 0 divided by 1 by 2 into 1 plus x to the power 1 by 2 minus 1. Now if you use the limit here, you will be getting 1 by 3 divided by 1 by 2. So the answer becomes 2 upon 3. So answer is 2 upon 3. Right? Okay. The correct option is option C. Correct? Got it? Okay. Sure. Let's move to the next question here. In this question also, it is asking to find the limit of this given function when extending to infinity. So let's see. F of x is given as x cube whole into x square on root of x square plus on root of x to the power 4 plus 1 minus x into root 2 this. Okay. Okay, if we'll take x to both outside. Okay. So, okay, I'm taking this x to outside. What is happening? Let's see. So this becomes x square plus, it will take x to the power 4 as common. From this root 2, it will be coming with x square. So this will be 1 plus 1 upon x to the power 4 minus x into root 2, right? And if we'll take x square as common from the under root to the outside, we will be taking common as x. So x into x x into 1 plus x to the power 4 to the power half minus x into root 2 this, right? Now if we'll take x as common also, so we'll be having x to the power 4 whole into 1 plus 1 upon x to the power 4 whole to the power 1 by 2 and also whole to the power 1 by 2 minus root 2 this. Okay. Now, if you'll use the binomial approximation, already all of you know what is binomial approximation. So now, how we can use the binomial approximations to evaluate the limit? That is 1 plus x to the power n is approximately 1 plus nx. All of you know this or not? Or also 1 plus n into nx plus 1 plus n into n minus 1 divided by 2 factorial into x square. Like that, right? Chalo. And so on. Okay. So if we'll use a binomial approximation in the given question, so if we'll use here in the inner wala portion, in this bracket or in this expansion, if we'll use the binomial approximation, so what we will be having? So 1 plus 1 by x to the power 4 whole to the power half. So this is approximately 1 plus 1 by 2 x to the power 4 plus 1 by, this will be 8 into x to the power 8 as 8 or what, n 1 by 2. So this will be actually minus 1 upon 4. Nah. Four into x to the power 8 and so on, right? So, but we will be using only these two terms because you can already studied now. You have already studied we should use the binomial approximation up to 2 decimal places. If you are taking more terms, then what will be happening? You can observe in the next 2 steps also, right? So I am taking the only first 2 terms of the binomial expression. So what do I am getting? After this, I am getting here x to the power 4 into 1 plus, this becomes, I'm in place of this, I'm writing here 1 plus 1 by 2 into x to the power 4 whole to the power 1 by 2 minus root 2. I'm taking this one, right? So now also you can see x to the power 4, this becomes 2 plus 1 by 2 into x to the power 4 whole to the power half minus root 2. See, again you need to use a binomial approximation to evaluate the limit, right? So but here we are having 2 in the expansion, you are having 2 instead of 1, right? So I'm trying to make it 1 also. So this becomes x to the power 4. If we'll take 2 as common from the expansion, it will be coming with root 2. So x to the power 4 into root 2, right? So this becomes 1 plus 1 by 4 into x to the power 4 to the power half minus root 2. See here. Now we can use the limit. Now you can use the limit. So actually in all the terms, you have to write limit extending to infinity. Okay. Limit. Okay. Let's see. Here you can observe here. Now you can use the binomial approximations here. So this becomes limit extending to infinity root 2 into x to the power 4. So this becomes 1 plus 1 by 8 into x to the power 4 minus root 2. Okay. Now you can observe here how why we didn't took the binomial approximations up to 3 terms, because now you can observe here you are getting x to the power 4 here, and also already you are having x to the power 4 here. So this x to the power 4, x to the power 4 will be cancel out. If you have taken that the binomial expansion up to 3 terms, then you will be having another term with x to the power, the denominator x to the power 8, and this will be when extending to infinity, it will be 0 also, right? So if we'll apply the limit here, what you are getting? Okay, let's see. Limit extending to infinity root 2 into x to the power 4 plus, here you are getting root 2 upon 8 minus root 2, right? So we are having with only, acha, so already we have taken this root 2 as common, na? Here we are having one, this is one. Okay. Okay. So this will be 1 will be cancelled out. So we'll be having only root 2 upon 8 into, if you rationalize it, this will be root 2. So 1 upon 4 root 2 we are getting. The answer is 1 upon 4 root 2. Okay. The correct answer is 1 upon 4 root 2. One upon 4 root is your answer. Clear? Okay. See, come to the next question. What you are having in the next question, guys? Okay. So for these questions, I'm giving you 2 minutes. Let's try to solve these questions. And your time starts now. Okay. Sorry for the technical issues actually. I hope my voice is clearly audible and also my screen is visible. Yes. Sorry for the technical issues actually. Sure. So let's solve these questions. What it is asking in the question to find the limit, right? Okay, let's see. In the question, it is given to find. I am giving you options. Options are 3. Second option is 4. Third option is 2, and last option is 1. Right? Let's see what is the answer will be. In the question, oh, actually, it's a numerical question. Now, let's see. No, these are not the options correctly in this given. Okay, let's solve this question first. In the question, okay, if you put the limit in the given question, what is happening? Extending to 0, that is actually 1 to the power infinity into e to the power infinity. So e to the power infinity becomes infinity. So this will be again infinity. So no, कोई फायदा नहीं फिर ये तो यूज नहीं कर सकते हैं फिर है ना. So one thing I'm suggesting, when you are having like these functions, limit extending to 0, something to the power infinity, 1 to the power infinity into infinity, like these functions, or in the power of the given function, again you are getting a variable. Okay, if you are having the function with a variable power, then you must use this method to solve or to evaluate the limit. So what is the method? Let's put log. I'm taking the given function as y as 1 plus 2x upon 1 plus 3x to the power 1 by x square, right? So if you are taking this like this, if you take log on both sides, I'm having ln y is equal to 1 upon x square ln of 1 plus 2x upon 1 plus 3x. Is it or not? Okay. So then y can be written as e to the power 1 upon x square ln of 1 plus 2x upon 1 plus 3x. Is it or not? Yes, we can write this as. Let's try this. Instead of 1 plus 2x upon 1 plus 3x all to the power 1 upon x square, we'll try to write e to the power 1 plus 1 by x square into ln of 1 plus 2x upon 1 plus 3x, right? So let's try. Limit extending to 0, e to the power 1 plus 2x, sorry, e to the power 1 by x square ln of 1 plus 2x divided by 1 plus 3x into e to the power 1 by x. Okay, so this is the limit we need to evaluate. Chalo. So let's see. Okay. Sorry, actually I'm facing some internet issues also right now. Right. Now, because e raised to some function is actually continuous. So when you are having continuous function in case of limit, then limit goes with the with the what instead to the limit, है ना? Then लिमिट जो है कंटिन्यूअस फंक्शन के पास ही चला जाएगा. दैट इज e रेज टू लिमिट एक्सटेंडिंग टू 0 1 upon x square ln of 1 plus 2x divided by 1 plus 3x plus 1 by x. Now if we'll take the LCM in the exponent of exponential, then what you are having, e raised to limit extending to 0, it will be x square, and this will be ln of 1 plus 2x minus ln of 1 plus 3x plus x. Yes or no? You'll be having this. Okay, now you can check. This will be in the 0 by 0 form. Okay, or you can use the, also you can use that method. You can use the logarithmic series also. 1 plus x वाला series को भी तुम use कर सकते हो यहाँ पे. Okay, so let's see. We'll use the L'Hopital rule first because it is easy to evaluate. E raised to limit extending to 0. This will be 1 upon 1 plus 2x into 2 minus 1 upon 1 plus 3x into 3 plus 1 divided by 2x. Again, you need to use L'Hopital rule because again you are getting 0 by 0 form. So let's see. Will you again differentiate e raised to limit extending to 0. So this will be 2 minus 2 upon 1 plus 2x whole square into 2 minus 3 upon 1 plus 3x whole square. This will be plus into 3. This is 0 divided by 2, right? So now you are getting, if you put the limit, you will be getting minus 4 plus 9 divided by 2. So that is e raised to pi by 2 will be your answer. E raised to pi by 2 will be your answer. Clear? Got my point? Sure. ठीक है. E to the power 5 by 2 will be your answer. Okay. Okay. So let's move to the next question. Then. Okay. Is there any doubt, guys? Is there any doubt in this question? If you have any doubt, you can ask. So answer is e to the power 5 by 2. Clear? Shall I go to the next question? Okay, let's move to the next question. Here, you are having, okay, in the question it is already given that limit e tending to e raised to 3, okay, ln x minus 3 to the power n upon ln of cos of ln x minus 3 to the power m. Achha, it is given that it is 1. Okay, it is already given that it is 1 minus 1, right? And you need to find n divided by m. Okay? So in such type of questions, so what should you do? First, see in the numerator you are having ln x minus 3, and also in the denominator you are having ln x minus 3. So my suggestion is to take, let's take ln x minus 3 as t. Okay? If ln x minus 3 as t and extending to e raised to 3 as extending to e raised to 3, then t tending to 0. That implies we can say t tending to 0. Is that or not? Okay. Then substitute limit t tending to 0 ln x minus 3, sorry, numerator becomes t to the power n divided by ln of cos the power m t. Okay, which is given as minus 1. Okay, no problem. Chalo, okay. If it is given, can you use the L'Hopital rule? Yes, we can use the L'Hopital rule also here. So use the L'Hopital rule. Limit t tending to 0, this becomes n into t to the power n minus 1 divided by 1 upon cos की power m to हो गया t into derivative of cos की power m, that is m into cos of m minus 1 of t into cos of x, cos of t derivative minus sine of t. Okay. Okay, now check. So this will be cancelled out. Okay. So finally we are having limit extending t tending to 0 n into t raised to n minus 1 divided by, this will be m into sin t upon cos t, that is tan of t, and tan of t, m into tan of t. Minus is already we have left. Okay, m into tan of t. Okay, so it is given that minus 1. Okay, it is given as minus 1. So minus minus will be cancelled out. So finally what we are having, limit t tending to 0 n into t to the power n minus 1 divided by m into tan of t is equal to 1. Right? Okay. Now see, if we'll divide this with t, then this will be n minus 2. Right? So n into t to the power n minus 2 is equal to 1. This will be 1. Okay. So what we are having, limit t tending to 0 n into t to the power n minus 2 divided by m is equal to 1. So this to be 1, t raised to n minus 2. So n minus 2 must be positive. Right? Agar n minus 2 if n minus 2 will be 0, then n is equal to 2. Okay, see, if n minus 2 is equal to 0, then n is equal to 2. Or this right hand side to be 1, m must be 2. If n minus 2 is, if you are taking any negative number, suppose I'm taking n minus 2 is greater than less than 0, suppose I'm taking t, if t can't be 0 ना, अगर t 0 हो जाएगा तो फिर t raised to t अगर t 0 to the power tending to 0 ना, so अगर t हम 0 डाल देते तो नहीं हो पाएगा. ठीक है. So t tending to 0 में n minus 2, this right hand side to be 1, n minus 2 must be equal to 0. Otherwise it will not be. Right? Because if we'll take t as negative number, then minus 1 to the power n minus 2 any number can be. So yeah, so we are getting m is equal to n is equal to 0, right? So n upon m is equal to 1, right? We are getting n upon m of n divided by m as 1, right? So this is our answer. Okay, chalo. If it is clear to all, let's move to the next question. Next question, it is given that you need to find the value of limit extending to 0 x to the power 6000 minus sin x to the power 6000 whole divided by x square sin x की power में 6000 is okay. So let's see. So this becomes limit extending to 0 x to the power 6000 minus sin of x to the power 6000. I am taking numerator same as and denominator के साथ थोड़ा मैं कुछ तो करूंगा. So this will be x to the power 6002 sin of x divided by x whole to the power 6000. Is there any problem? I can take or not? Yes, I can take. So you are having with chalo. If we take x to the power 6000 as common in the numerator, so what we will be having? Let's see. Limit extending to 0, 1 minus sin of x to the power 6000 divided by x to the power 6002 sin x upon x whole to the power 6000. Okay. So this will be cancelled out with this. So finally we are having limit extending to 0, 1 minus sin of x divided by x to the power 6000 divided by this will be x square into this. This will be 1 now, x square into sin of x divided by x to the power 6000, right? Okay. Now just a minute. Is this given? Okay. Now extending to 0, this will be 1, right? X minus sure. ये तो 0 by 0 फॉर्म हो जाएगा. फिर if you'll use the expansion of sin x, right? If you'll use the expansion of sin x in place of sin x, then it will be x minus x cube by 6 divided by x up to 2 terms we will be taking only whole to the power 6000. In the denominator also you will be having x square into sin x upon x to the power 6000, right? Okay. Now you can say you will use x to the power 6000, you are getting here and it will be 6x minus x cube by x to the power 6000. So finally it will be simplifying with limit extending to 0, 1 minus x square by 6 to the power 6000 divided by x square into sin x upon x whole to the power 6000. Now, if you use the binomial approximation in the numerator, what will be you will be getting? You will be getting limit extending to 0, 1 minus of 1 minus 6000 into x square upon 6, and it will be 1, right? So this will be x square into x sin x divided by x to the power 6000, right? Now if you'll put extending to 0, this will be 1, and x square will be cancelled out. You'll be getting only 1000. So the correct answer is 1000, right? This is your answer. Okay. Now, if we'll go to the next question here. Oh, which of the following statements is true, right? So in the given question, it is given that let f and b, f and g interval -1 to 1. Okay. And such that their real value defined in the interval -1 to 1 such that g double dash of x is continuous. So it is given that g double dash is continuous. G of 0 is not equal to 0. G dash of 0 is equal to 0. G double dash of 0 is not equal to 0. And f of x is equal to g of x into sine of x. That's in the first statement. Okay, we're not having the first statement. Okay, the first statement is given that limit extending to limit extending to 0, g of x into cot of x minus g of x into cosec x is equal to f double dash of 0, right? And also in the second statement, it is given that f dash of 0 is equal to g of 0. So from the given statement, from the given question, we can take, we have an informations, that is f of x is equal to g of x into sine of x, right? Okay, if you'll differentiate on both sides, what you are getting? You'll be getting f dash of x is equal to g dash of x into sine of x plus g of x into cos of x, right? If you'll take f dash of 0, then what you are getting? G dash of 0 into sine of x plus g of 0 into cos of 0, right? So cos 0 is 1 and g dash 0 is given as 0. So this becomes 0. This is g of 0. We are getting g of 0. So f dash of 0, we are getting f dash of 0 is equal to g of 0. So my second statement is true, right? My second statement is true. Clear? Okay. So let's check this first statement. So in the first statement, we are having in the right hand side of the first statement, we are having f double dash of 0, right? So we got f dash of x as g dash of x into sine of x plus g of x into cos of x. If we'll take f double dash of x, so this then it will be g double dash of x into sine x plus g dash of x into cos x plus g dash of x into cos x minus g of x into sine of x. Okay. So in the right hand side of the first statement, we are having f double dash of 0. If we take f double dash of 0, then it will be g double dash of 0 sine 0 plus g dash of 0 cos 0 plus g dash of 0 cos 0 minus g of 0 sine 0. So you can see here sine 0 is 0. So this becomes 0. G dash 0 is 0. It is given. This is 0. It is also 0. This is also 0. So we are getting, finally we are getting 0. We are getting f double dash of 0 as 0. Right? F double dash of, now come to the left hand side of the statement 1. So in the left hand side of the statement 1, it is given that this, okay. Limit extending to 0, g of x into cot of x minus g of x into cosec of x. Okay. Now, if you try to evaluate the limit, this will be limit extending to 0, g of x. This can be written as cos x upon sine of x minus g of x into 1 upon sec x. Oh, sorry, sine x. Right. So this will be limit extending to 0. G of x will be taking as common, then we will be having cos x minus 1 upon sine x. Okay, now you can see limit extending to 0, g of x into, if we take minus as common, and 1 minus cos x by sine x. So 1 minus cos x upon sine x is tan of x by 2. Okay. Now, you can see in the question, when we will put limit extending to 0, then tan of x to x by 2 will be 0. Yes, we know this. Okay. So this, because right hand side of the statement is 0. So this to be 0, this left hand side to be 0, if g of x becomes finite. If we'll prove that g of x is finite, then statement 1 will be true. So let's see, in the given question, it is given that, g double dash of x is continuous. Okay. In the question, it is given that g double dash of x is continuous. Okay. That means g of x must be continuous, differentiable, and also continuous. If g of x is continuous and differentiable, if g of x is finite, then this limit will be 0. That means statement 1 is true. It is true. Statement true is, or 2 is also. And in the given option, what it is? Two is the correct explanation for statement 1. Second statement already, if from the second statements we are getting f double dash of x is equal to 0, right? For the first statement of, for the right hand side of the first statement to be 0, f double dash of x is equal to 0, 0. Okay. So actually option A will be the correct answer, because f double dash of 0 is equal to 0, you are getting from the statement 1 only. And when you are getting f double dash of 0 is equal to 0, then the left hand side of the given statement 1 becomes 0, then the second statement will be the correct explanation for statement 1 also, right? Then this is the question. Okay, it's very nice question actually. Okay, I hope this is clear to all of you guys. It's time to end the class now. Let's see you in the next class. Will be continue the topic limit continuity and differentiability in the next class also. We'll be solving some more PYQ questions in the next class. Okay, so till then, take care. Bye bye. Take care.